Hello everyone, Bradley Sward here, and this video today is the 2022 Advent of Code solution for Day 12, Part 1 of the problem known as the hill climbing algorithm. So in this case, basically you have a starting point and an ending point, and it's basically kind of like a pathfinding routine where you're trying to find the quickest route from there, and you can only move up one letter at a time, and according to this, you can move down as many as you want. You basically just make a giant fall, but you can only go up one square at a time. So you can see here, following this example, this shows you exactly how to get from the start to the end if that's all you have to it, and this is the shortest path available to you. Not saying it's the only path available to you at the shortest distance, but we only care about the number. We don't care about the actual path involved at all, slightest bit here. So in this case, it's 31 steps to get from point S to point E. And so for my example here, I got the puzzle answer of 420. How did I do that? I did that with this code right here. So there's a lot of code here. I can't really put this on, can't really put this, actually, what happens if I do that? Let's see, get this in one. There you go. There's the whole thing. And so a lot of this was just getting the data into a specific format and setting up so that I have a start position and an end position. And at some point I reversed my start and my end because I figured maybe it would be a little faster just based on the math, but apparently, or just based on the data that I was looking at, and apparently it's probably about the same speed to go from, basically I'm working my way backwards from the end position back to the start, but it really doesn't matter. As long as you follow the rules, it works both ways. And you just use a mirror image of the values for the current stuff. So that's my input. And then once I have that, I'm maintaining a list of lists, I guess, or a list of lists, and each one of the individual elements has my basically my current position and then all the other places I've been to along the way when it comes to a specific path to get from start to end, because again there can be many paths, and basically you never know truly which one is the best one, and maybe some of you guys know better than me. It's been a while since I've thought about this problem, but basically as I go, I'm going to keep track of all the paths, and basically when I get to a position where I go, oh, I've already been there in some form, shape, or form, either in my own traversal of my own path. If I go back to a square I've already been to, well, there's no reason to do that because then that's a recursive behavior and I'll never be able to find a way out. Or the same goes for any other path that I'm currently exercising and thinking might be the current best path. Because if we do this as a breadth first search, and I keep using this as a cue, this little thing here, this paths as a cue, that basically if I try to find a position on the or in somebody else's queue that they've already been to, it's the same idea where they did it faster. They already got to a position faster, and so therefore I don't need to pursue this path any longer because I got to a position further along than someone else did, and they're doing it better already, so I don't have to consider that path. And so I wrote some code to handle that situation here, and this little function says, just based on my setup here, that if I'm looking for a specific position, if it's in this data structure in any shape or form, and of course, again, I got it working, that doesn't mean I have it as efficient as, even close to as efficient as possible. But so basically, if that position is inside of the path's current position or any position it's ever been to, then I'm basically going to say I don't need to continue this path along, and I say false. It's all, and I did this just to make it easier on myself. I reversed the logic here. Is not in the closed list, and I go, yeah, it is in the closed list if I find it, and if it's not in the closed list, if I go through everything and I can't find it. So then, just to kind of finish up here, oops, make it even smaller for you guys. Then basically all I'm doing is starting with my initial starting position. And I'm just going through and going, can I go up? Can I go left? Can I go down? Can I go right? Following all of these rules, basically saying, well, I want to make sure I don't go off the grid. That's the part of this stuff here. And I also want to make sure that it's not in, I guess I could remove this, is not in the closed list because that is now covered by this, I believe. I don't want to touch it. Maybe run it. Well, it takes a little while to run on my end here. And so you can say, but basically you're just checking, is that position that I want to move to, up, down, left, or right, already in somebody else's lists? And if it's not, then I'm going to add it in. And basically just a lot of fancy math to do that. And I'm not 100% familiar with references and the way that Python continues to move data around, which is great. Again, I come from a C++ background where I love to explicitly see this thing in action, and I'd love to see the references and the pointers and all that so my brain can wrap my head around it. But anyway, if I can, I add that to my list and I try all 4 directions, and then I remove that thing from the list and I just carry on. And when I find the first one, and again, it takes a little while here, but it does come up. Well, yeah, there it is. 420 is my answer, like you saw before. And basically, it took 420 steps to get from point A to point B, or from point S to point E. So part 2, I'm going to see if I can get to part 2, and see if I have the time. Usually, it requires me to tweak this thing up a little bit, but it's more of a do I have time to do it kind of thing than anything else. So thanks for having a great day. Hope you have a great day. If you have any questions or concerns, let me know. Thanks for watching these videos. Those of you who do, appreciate it. And hopefully see you guys in either part 2 or day 13 pretty soon. Take care, everybody. See you later.